All right, hey everyone, welcome back. Today's video is about lenses. The things you need to know before this is what is refraction and the two ways that refraction can occur. What we're going to be talking about in this video is we're going to define what a lens is, and then we're going to examine how lenses form an image. Now, starting off, I want to remind you of the two ways that light can refract, and what I mean by this is by bending towards the normal line or bending away from the normal line. And this happens depending on if you're going from a less dense to a more dense medium or from a more dense medium to a less dense medium. Now, up till this point, what we've observed is boundaries that are a straight line. Okay, the boundary between air and glass here is a perfectly horizontal straight line. Now, this is significant because if you draw a normal line at this point here, you'll get this nice dotted vertical line. If we were to draw the normal line at this point here, what it would look like is also a nice straight vertical line. Now, if you were to draw a normal line for, say, this point here, nothing is different. We'll get a nice vertical line. Each of these vertical lines is the normal line at that point along the boundary. Now, imagine we didn't have a straight line boundary and instead we had a curved boundary. So here is my curved boundary. Now, to the left of this is air, and to the right of this is glass, a more dense material. What I'm going to do is draw three normal lines. First one at this point here, second one at this point here, and the last one at this point here. Now, for the first point here, the normal line will be a nice horizontal line. This is the normal line because normal means perpendicular, and this line makes a 90-degree angle with the boundary there. Let's do a similar thing for the point at the top. Now, a normal line is a perpendicular line through that point. I don't want it to be red, I want it to be black. A perpendicular line, just like that. Now, this is a normal line for that point because it also makes a 90-degree angle with the boundary line. Now, for that last line at the very bottom, just for demonstration purposes, here is the normal line at this point here, and it also makes a 90-degree angle. Now, the point I'm trying to make here is that for every different point along the boundary, you'll have a different normal line. Now, why is that important? That's important because if your normal line is different, your refraction will be different. Let's demonstrate that. For this middle point here, if we had a ray of light that came at it with a perfect horizontal line, it makes 0-degree angle with its own normal line because it's on top of its own normal line. What that means is that the refraction will just be straight through. There will be no refraction at all, and the light will just pass right on through. For the one at the top, if we had an identical ray of light, a nice horizontal ray of light that comes like that. Now remember that we're dealing with a less dense material going to a more dense material. That means our incident angle, theta I, will be larger than our theta R because our refraction will be towards the normal line. So let's draw a line of refraction that bends towards the normal line. Just like that, just to demonstrate it to you. Theta I is bigger than the theta R here. Okay, that's the nature of going from less dense to more dense. Let's do this one more time for that line at the bottom. A ray of light approaches the medium, perfectly horizontal, or as close as I can get it, and it will refract towards its normal line because we're going from less dense to more dense once again. So we'll get a line that's similar to this. The point I'm trying to demonstrate is that for every point along this curved boundary, you have a different nature of refraction. This is because you have a different normal line at every point. Now what we're going to say is that a lens is a medium with a curved boundary. So this drawing that I drew over here, this boundary here is considered a lens, okay, because it's a curved boundary. This boundary in our diagram to the left is not a lens because it's not a curved boundary, it's a perfectly straight boundary. So what we're moving from is the straight boundaries towards the curved boundaries, and the curved boundaries are called lenses. So here's our definition for a lens. Now let's talk about a very common lens called the convex lens. Now the rays of light all approach perfectly horizontally and in the same direction. Now these three in the middle, you can see that their resulting refractions are not that much. They don't bend so much as compared to the ones on the edge. So the ray of light comes through, bends twice because it enters a new medium twice, but the amount it bends on the edges is a lot more than they're bending towards the middle. Each of these rays of light have a different refraction because they have different normal lines. As a result, the light rays all exit at different directions, and because they have different directions, there will come a point where they all meet up. The point that they all meet up will be called the focus or the focal point. Now let's try to connect everything now. First, we'll go with a little biology lesson really quickly. This is a cross-section of your eyeball. At the front of your eye, you have the cornea, the pupil, and the iris. The pupil is the little opening, like little window that lets all the light through. Here, this is labeled as a lens. Inside your eye, you have a curved medium, and it's called a lens. It's a see-through medium, and it refracts the light through it. At the very back is the retina. The retina is like a sensor. It's kind of waiting for the light to reach it so that it sends the picture to your brain. Let's talk about what light does as it enters your eye. So light enters your eyeball, and your pupil is opened up. It's allowing the light to go through. Now, each ray of light refracts differently because it will have a different normal line. I'm only drawing 3 for demonstration purposes. The one in the middle will go straight through because it makes a 0-degree angle with your lens. The top one will bend a little bit more, and the bottom one will bend upwards. Now, what happens here is that all of the light focuses right, that's not, I want a pencil. It focuses right here, still not doing a pencil. How do I do pencil? There you go. So it all focuses and lands right here at this point. Now this is where your retina is, and this is where the retina is waiting for all the light so it can form a picture and send it to your brain. Now this is nice and happy. Now here we have a different eye. It looks exactly the same, but I'm telling you that it's different because the lens, the pupil, the cornea are all shaped a little bit differently. And the light still goes through the same way, but because the lens and the cornea may be shaped a little bit differently, the light rays will refract a little differently too. And they're not going to meet up all the way at the back where the retina is. Let's say that this top one refracts a little bit more, and this bottom one refracts a little bit more as well. And instead of meeting up at one point on the retina, it will meet up at some point right here at a distance from the retina. Now what the retina is receiving is rays of light that are coming from all different directions, and it doesn't like that. I'll talk about why in a second. So for the first eyeball, our rays of light all land really nicely on the retina, and in our second eyeball, our rays of light land a little bit in front of the retina. Now there's a third scenario, I'll try to draw it out really quickly, where instead of the light meeting up somewhere really forward, the refraction doesn't happen as strongly as it should, and the rays of light never meet up inside the eyeball, and instead they meet up at some point outside the eyeball. Now this point outside the eyeball is again a distance from the retina, and the retina still receives different rays of light, and it's not focusing like it wants it to be. Now imagine, let's take this blue eyeball as one more example. And instead of having these rays of light, what we're going to do is put an extra little lens in front. Right here. We're going to put a lens in front. Now what this will do is the light will come through. It will bend at a particular angle. And because the entering purple rays are bent a little bit differently than the initial blue ones do, the resulting purple rays of light, will focus on the back of the retina, and you get a nice focused picture at the back of your retina. Now what this lens is nothing different than what you already know as glasses and contact lenses. So glasses are lenses that you put in front of your eye such that it bends the light just enough or just a little bit less to compensate for the lack of focus that's happening inside your eye. Let's talk about that one more time. I'm going to put a set of glasses in front of this eyeball. And a set of glasses is nothing but a curved boundary. And let's do the rays of light in red. Rays of light will enter horizontally. They will bend at a particular angle depending on how strong the lens is, how far the lens is from your eye. And because these rays of light are no longer horizontal anymore, they're a little bit angled, their corresponding refractions will also change. The rays of light all focus at the back of the eye where the retina is waiting for them. And the retina is happy because it's collecting all the rays of light at the same place, and you get a nice clear image. Without this lens, you will not get a clear image because your focus will be somewhere over here or somewhere over here. The difference between this and this is whether or not you're short-sighted or far-sighted. Now, that's the difference between seeing a blurry image and a clear image. You see a blurry image when your focal point is not on your retina, and you see a clear image when your focal point is landing exactly on your retina. When the rays of light are not landing on your retina, you need to adjust for them by wearing lenses. And a lens is just an extra piece of glass that sits at the front of your eye that bends the light just enough so that your retina gets all the light in the same place instead of too far forward or too far backward.